Hello everyone, I want to use this video to show you more instructions about Lab 6, internal process that shape our Earth. Okay, so in the lecture, you know our Earth inside you have a lot of energy from Earth's core, from mantle, it's restless in internal layers. And those internal processes are powered by those internal energy of our Earth. Okay, and you know the net energy from the Earth's inside they want to get out. Okay, they break our plates into different pieces. We call them plate tectonic plates. Okay, that's what you learned in the lecture. But the first question actually is very straightforward. I want you to label it. Label all these major and relatively smaller plates where it is. So for example, where is Pacific plate, you put a name here, Pacific plate. Okay, so I think the animation I sent to you over the weekend is very useful. Let me direct you there. Okay, so you can see this is the plate boundaries and you have a map here. That's exactly the thing you want to write up. Okay, and you can see here also show you three types of the boundaries between different plates. If they're moving away from each other, that is your divergent. The convergent is moving towards each other, and this transform boundary is slide past each other. Okay, so this animation I found it is very helpful. Okay, so that is for your question number 1. Okay, so let's see. The second question, really, when you have those plates, you know which is which, right? You want to identify the type of the plate boundaries. Is convergent, divergent, or transform, okay, at the following locations. So, where is your Aleutian Trench on the ocean floor south of Alaska? In your lecture slide, you have it, but let me label it here. Okay, your Aleutian Trench is this one. Okay, your Aleutian Trench is this one, south of Alaska. Okay, and it's divergent or convergent. Himalayas. Okay, Himalayas, where it is? Himalayas is here. Okay, between Indian subcontinent and Eurasian continent, right here. Right, okay, and where is your Peru-Chile Trench? You know Peru-Chile Trench, right? It's right here. Okay, so you can see all these three places. You will have this like sort of like your cold front, those symbol like this. Okay, this actually indicating, you can see this actually Nazca plate moving towards South America plate. Okay, this should be a convergent boundary. Okay, so you move on, mid-ocean ridge, cross Iceland. Where's Iceland? Right here, okay, Iceland. You can see, oh, we changed that, it changed to red, sorry, to red, what's that, okay, and then Yuku Island arc in Southeast Asia, okay, you can read from the symbols. Oh, by the way, those white arrows represent to which direction it's moving. So you can see cross Iceland, you have the arrows on this side this way, on that side that way. So what kind of thing? What kind of plate boundaries? Okay, Ryukyu Island is right here. Okay, from Japan, extend from the south tip of the Japan all the way to Taiwan. These places. Okay, Ryukyu Island, and also Mariana Trench and East Africa Rift Valley. Okay, Mariana Trench is right here. Okay, it's right here. It's a curve. Okay, and then Rift Valley is here. East Africa Rift Valley. Okay, and see. Okay, so San Andreas Fault. I don't have to show you which this one is, right? This one is right at home. It's right here. Okay, so change to yellow. Okay, based on the movement, remember this is a relative movement. It's not absolute movement. Means you refer to the neighbor plates. For example, Pacific plate moving this way, North American plate also moving that way, but Pacific moving faster. So it's like Pacific moving this way, relatively South America moving this way. It's just like two cars in the two lanes. They're moving to the same direction, but this car is slow. And if you are sitting in this car, you will feel, oh, this car moving to the opposite direction. Okay, so what kind of boundary it is? Okay, so that is the second question. Then, based on your finding here, okay, we have a lot of mountains, right? We have like Himalaya mountains, island arcs like our Ryukyu Island or Aleutian Island in South Alaska, right? Ocean Trench, Peru-Chile Trench, okay? Ocean ridges like mid-ocean ridge cross Atlantic, okay? Rift valleys and strike slip fault like our San Andreas fault. You just need to connect, okay? It's created by convergent boundary, divergent boundary, or transform boundary, okay? So based on your findings here in the previous question. All right, so that is the second one. The third one, you need to explore a little bit more, okay? This one shows you a map. So down here, let me zoom out a little bit. Okay, so this is a tectonic map of hypothetical ocean basin. So let me zoom in. All right. Okay, so you can see this is the land. This is another land. Okay, and in between is your ocean basin. Okay, and you can see you have a lot of symbols. Okay, down here, read these symbols. What does that mean? Okay, so you can see here, if you have those D, that means deep focused earthquake, means that earthquake happened very deep in the crust. Okay, I means intermediate level, the depths, and S means shallow focused earthquake. Okay, and you can see it's very weird. Okay, so along here, sort of like you have a line, you have the earthquake from shallow to intermediate to deep, and then go beneath this island, this continent, right, or island. Okay, but you have a chain of island here, and if you see triangles here, that means all these islands, you have active volcanoes. Okay, all right. Okay, so it looks like in our Aleutian Island, isn't it? If you've been there, Aleutian Island, all these islands, you have volcanoes on those islands. It's all volcanic, okay? And you have earthquake, an earthquake from this direction into the I blank out the name of this ocean, but go to deeper and deeper and deeper. Okay, so why you have this? Can you picture what's going on between this plate and that plate? Okay, so that is the thing. And here in the middle, okay, you have a lot of those circles with number. That is the age of the rock at that spot. Okay, so if you zoom out a little bit, you can see, okay, this is the shallow focused earthquake, and you have very young rock, right? But if you go further away from these young rocks, you have older rocks. Okay, hint, mid-ocean ridge. If you're away from mid-ocean ridge, you should have older and older rock because they move this way, right? They're separating. So go to your lectures to study, oh, those divergent boundary. Okay, divergent boundary. You have those two plates moving away from each other. You have the lava oozing out, right? Okay, so you can see you have a newer rock here, but those plates will carry the older rock away. Right? Okay, so that's the hint what kind of plate boundary it is. Okay, and also when your plate moving this way, okay, they also send the island moving that way, right? And when your island is far away from this fissure of lava, then it's distinct. Think about our Hawaii Island, right? Okay, so that is another hint. Towards this side, you see the same. right? You see the same, but it's shallow, intermediate, and deep. It's opposite, okay? And you have volcanic mountains right here. Okay, so that is a hint to read those maps. The key is to understand those symbols and to use the landscapes, okay, associated with each boundary. Okay, so you can see you have divergent boundary. This is the movement of divergent boundary, right? Okay, you have convergent boundary, but convergent boundary can happen between ocean and your land. Okay, if your land is a continental plate, okay, majority of the most part of this plate is continental, then we'll call that continental. But on the edge, you have a little bit ocean. So I will give you these volcanic arcs. Okay, and if you just have like land like here, okay, like Pacific Ocean, Nazca Plate plunged beneath South American Plate, okay, you just have the volcanic mountains. Okay, or it's like our Juana Fuca Plate plunged beneath North American Plate, you have volcanic mountains down here. Okay, so the setting cross section is just like this. Okay, so the key really is to go back to your book or our lecture presentation to study the plate boundary, the types, what kind of landscape, what kind of landforms is associated with that type of boundary, and to study this cross section, because the last question I want you to draw approximate cross section from A to B. So you're going to draw a line. Let me draw a line. Okay. Let me see how that happened here. From here to B. Okay. So this from the top, right? From the top you just see the land and the ocean. Okay. What happened beneath it? Okay. What happened inside the Earth's crust? Okay. So the hint is you go to this cross-section view. Now this is the map view you see from the top, right? Cross-section view is like a side view of what's happening. Okay, so I hope you can refer to those examples to draw a cross-section for me for this hypothetical ocean basin. Okay, from A to B. This is the land, ocean here, this is another land, right? Okay, so I hope that is, yeah, okay, and read those questions carefully, what I'm asking about. Okay, so that's it. It's a relatively easy and straightforward lab, but I hope it can give you some help on understanding our internal processes, specifically is our plate boundaries, how they shape our landforms, how they shape our Earth. Okay, all right, and your discussion, you have a opportunity to explore earthquake, and we can focus on that to explore volcanoes in our lecture. So that's my plan for this week. All right, I will see you in our lecture. Bye for now.